So this is the x equal. After that, everything the b bar will be present. So here look at the direction. Now this is the e bar. B bar is present parallel to x-axis. And let's see what actually happens. So here the charge particle will enter the origin with a speed v, and then because of electric field, along y-axis. Anything will happen to charge particle. It's going to describe what is the path. Path will be parabolic path. So when it arrives here, the charge particle, it will have two components, no? Vx and Vy. This distance is what given for us, x equal to e. So at t equals 0, it is here. After some time, say t1, it will arrive at this point. So what is Vy? Vy is equal to Ay into T1. Ay is Qem into T1. This is. So then Vx is equal to V only, initial velocity. Oh, potential difference. So let me assume V naught. Later on that V naught I'll bring in terms of potential. So Vx must be equal to V naught only because the electric field is there. So what is the time T1? We can calculate time T1. V naught is equal to A by T1. So substitute this here. You'll get Vy is equal to Qe m T1 will be A by V naught. He has given potential difference. So QV should be equal to half mv square. If you get in this one, so because when it passes through a potential difference, it will gain electric energy. So what is V naught equal to again? 2QV by m. This will be the relation between V is what? Potential difference. So look at the particle. Particle get the charge particle having a positively charged particle having charge Q is accelerated by a potential difference V. So when it get accelerated by potential difference V, it will acquire kinetic energy. That is what I assumed it. So later part will replace all that one. Okay, let's see that I got Vy in terms of this kind of. So what is further? A you can write it as QE, no? So this will become QE by M whole square by V naught. Keep it here. And now it's a parabolic path, no? This is then once it enters magnetic field, here magnetic field is present along x-axis. And there is no limit as given. So till x very large distance, magnetic field is present along x-axis. So what will happen to charge particle now? Look at one component of velocity is there along b bar, other component perpendicular to b bar. So it should be helical path. So here the charge particle is going to describe an helical path. And this should be the axis of helix. About 2, 3, 4 lines. What should be the radius of helical path here, and what should be the pitch, increasing or decreasing pitch? So B bar will not do any work, no?
Constant.
So pitch will be constant. Radius will be constant. 2r. So write down all the, again the same mathematical equations what we have. Radius depends upon r mvy by qb. The time period is independent of that. Time period depends upon 2 pi m by qb. And the pitch depends upon Vx into T. Can you hear me?
Sir.
Okay, I'll continue here then. Okay, this is about the helical path. So substitute all this one. So what are the types of question? As the increased potential difference, what will happen to time period of revolution of the particle in helical path? What we have to say? I think the time period is independent of what? Speed, no? With what speed the particle enters the magnetic field, that will not determine. Check it. If I increase the potential difference, definitely what happen? V naught will increase here. Then what will happen to the time period of revolution will not change. Radius of the revolution, or sorry, radius of the helical path. The radius depends upon the V naught, no? You can see that Vy, here V naught has come. So what should happen to radius of the helical path is going to change here. So as they increase the potential difference, what will happen to pitch, what will happen to the time period,